Speed of Sound Lab video documentation. I don't have a lab partner to drop the basketball, so I'm going to make a robot to do it instead. so I finished making the robot, and now I'm gonna hang it to the basketball hoop, and then control it with my iPad using Bluetooth. Now I'm gonna put the basketball into the robot hand arm thing. Okay, when I end this program, it should release the motors and have the ball drop. So, I'm gonna test it right now. It did not work. So now I'm gonna I'll put in a second program to open up the motors instead of just release them. I added a second thing to the program to have it open up the motors instead of just release them, so let's test this out. As you guys can see, it was a success. One last thing I've added is a 10-second timer, so I can go and run 200 meters away and then have the ball drop. I tried hanging up the arm onto the basketball hoop, but when I went 200 meters away, I couldn't see the basketball anymore, so I'm gonna go and try to find a more open space. Okay, I arrived at the new destination. It's an open field. This isn't pavement or cement or anything, but I think it'll still work fine because the sound is loud enough. So, now I need to try and hang it up in one of the trees. Okay, so I was able to get the basketball and the robot arm thing into the, hanging off the tree. So now I'll begin the experiment. Okay, so I've been trying to drop the basketball onto the grass. When I go the 200 meters, I can't hear it anymore, so I'm going to now drop it on my skateboard. the robotic hand thing, like, doesn't hold the basketball up, so I'm gonna use this wire to keep it up. And then when it, like, expands to release the ball, this will also come apart, like this. Okay, so I completely forgot about this lab, and now it's 1 o'clock in the morning, and I have to give in this video and submit it by 9, so I can tell my physics teacher I've completed the optional lab. And that's why I'm in different clothes as well. For this lab, we assume that the speed of light is instant, and that the delay between when we see the ball drop and when we hear it will be the amount of time that it took from the sound to travel to our ears. For the distance, I was only 169.58 meters away, even though that the instructions said at least 200 meters away, because I could not see any farther than that. Like, if you're gonna do this lab and try to get like good results, I recommend that you use binoculars or something like that. For the first trial, I got a time of 0.7 seconds. For the second trial, I got a time of 0.76. And for the third, I got 0.59, giving me an average time of 0.693 seconds. In the end, this gave me a speed of 244.7 meters per second. I later went and searched up what was the time that should have, like, been the one that I got. And I should have gotten a time of 0.494 seconds and have gotten an average speed of 343 meters per second. I think that my time was, considering the distance and then the amount of time that I was off by, was reasonable. It was around 0.2. And I also had searched up what was the average reaction time, and it was also 0.2, so yeah. Although my speed was about 100 meters per second off. If you do this experiment, I recommend you use binoculars and stand a very far distance away. And this robot arm, the one that I used to drop the ball since I didn't have a lab partner, it was really, many of the tests that I had done couldn't actually give me any data because sometimes it did not work properly and drop the ball at the correct time, which I had put into the timer, and sometimes, the motors would release and just not drop the ball at all, and sometimes it would just drop too early. So I would also recommend that you do not try this robot thing and instead go and get a lab partner.